Let's solve a two-dimensional motion problem where we need to find the position where an object comes to rest momentarily. Here's our problem. An object starts at the origin at time 0 with an initial velocity of negative 14 I minus 7j meters per second and has a constant acceleration of 6 I plus 3j meters per second squared. We need to find the position where the object comes to rest momentarily. Let's visualize this motion in a coordinate system. Here's our xy plane, with the object starting at the origin. The initial velocity is pointing in this direction, and the acceleration vector is pointing in this direction. To find when the object comes to rest, we need to use the velocity equation. Velocity equals initial velocity plus acceleration times time. When we plug in our values, we get this vector equation. When the object comes to rest, its velocity is 0. Setting this equation equal to 0 and separating the I and j components, we get negative 14 plus 6t equals 0 for the I component, and negative 7 plus 3t equals 0 for the j component. Solving either equation, we find that t equals 7/3 seconds. You can verify that this time works for both equations, which is a good check that our math is correct. Now that we know when the object stops, we can find where it stops using the position equation. Position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. Let's plug in our values. The initial position is 0, since we start at the origin. The initial velocity term gives us this vector, and the acceleration term gives us this vector. Adding these vectors together, we get our final position, negative 16.34 I minus 8.16 j meters. This is the point where the object momentarily comes to rest,